Welcome to qnawire.
Okay, we've got to draw something from a name and then name a few things. So let's start with the drawing something from a name. We're told that it's 3-heptene, and we're also told out front that this is a Z-heptene. What that means is that we have a 7-carbon chain, that's from the hep, and that it contains a double bond. We know that from the alkene or the ene, and that the highest priority substituents on this double bond are on the same side of the double bond. So we've got a double bond on carbons 3 and 4. Great. Now let's look at some of the other clues from our molecule and determine what else we know about this double bond. So we know for a fact that there's a 4-ethyl, so there should be an ethyl coming off of carbon 4. We established that this is carbon 4 and this is carbon 3. We know that there's a methyl on carbon 3 from the 3,6-dimethyl. So there's a methyl. But what we need to determine is if the methyl and ethyl are on the same side. So because we know this is 3-heptene, we know it's a 7-carbon chain. If this is carbon 3, then we need a carbon 1 and 2 on one side of it, and we also need 5, 6, 7 on the other side of it. So let's arbitrarily put 5, 6, 7 here. 5, 6, 7. 6, 7. Now we know we need a 2-carbon chain coming off the left-hand side as well as a methyl. We know that it's Z, so the highest priority group should be on the same side. So we'll put the 2-carbon chain on the same side as the 3-carbon chain and the methyl sticking off here. All right, let's continue. So now we've got carbon 1, 2, 3, 4, 5, 6, 7. We've got a methyl on 3 from 3,6-dimethyl. We also need a methyl on 6. And we've got our ethyl on carbon 4 right here. This is the named molecule. Okay, let's continue. Now we've got to give an IUPAC name for this molecule. Great. The first thing we want to do is find the longest chain in this molecule. 2, 3. That's a 6. So we know it's going to be hex somewhere in the name. The next thing we want to do is determine what kind of substituents are coming off of this 6-carbon chain and or the nitrogen. For example, we've got a methyl coming off of nitrogen, another methyl coming off of nitrogen, and a third methyl coming off of nitrogen. So at some point, we're going to have trimethyl in the name. The other substituent that we have is our bromine, so we know we're going to have bromo in the name. Next thing that we can do is number these carbons such that the nitrogen substituent will be attached at the lowest possible number. So we either need to count right to left or left to right. So if we go 1, 2, 3, 4, 5, 6, nitrogen would be attached at this 4th carbon. If we go 1, 2, 3, nitrogen will be attached to the 3rd carbon. So we do want to start numbering from here. 1, 2, 3, because 3 is lower than 4. Great. So since our nitrogen is attached at carbon 3, we know that we have a 3-amine. Now we can start kind of putting this stuff together. So our substituents are bromo, trimethyl. We want to name the substituent or list the substituents in alphabetical order. Bromo comes before methyl. The amine is the root name because it's the highest priority substituent, so that's not considered in our alphabetization because it'll come at the end of the name. So we go 6-bromo because our bromine is attached to carbon 6. And then we do our trimethyl, and to mention where those methyls are coming off. The ones that are attached to nitrogen get denoted as italics N. So it'll be N, comma, N, comma, and then carbon 4, 4 dash trimethyl. And then we list what the chain type is, which is a hexane. It's an alkane, hex, and then we cap this off with where our amine is attached, 3-amine. That's 6-bromo NN4 trimethyl hexane 3-amine. Okay, one last thing to name. This is a cyclohexane. With an ethyl group here and a bromine here. Another way of drawing this would be, since we know the hydrogen here, the bromine and the ethyl group are trans to each other. We could say wedged bromine dash to ethyl group. Okay, so now we've got cyclohexane with a bromine and an ethyl, and we need to essentially determine, is this 1-bromo 4-ethyl or 4-ethyl, or 1-ethyl 4-bromo. So we will want to name this such that the bromine has the highest priority and gets numbered as carbon 1, while the ethyl will be carbon 4. So we're actually going to say 1, 2, 3, 4. The last thing we've got to do is determine what the stereochemistry of carbons 1 and 4 are, so that we can assign the stereochemistry in the name. So let's look at bromine. We know there's a hydrogen in the back. Great. Now we can look at the substituents on bromine. There's a carbon to the left and a carbon to the right. In fact, this is a symmetric molecule, so there won't be stereochemistry because this substituent is the same as this substituent. So for that reason, we can ignore the stereochemistry and simply state that this is 1-bromo 4-ethyl cyclohexane. And we could state that this is trans 1-bromo 4-ethyl cyclohexane because the bromine and the ethyl group are on opposite sides of the ring.